On a beach at Camp Pendleton, California, an 18-ton armored vehicle rolled off the sand, pushed straight into the Pacific surf, and kept going. No landing craft, no barge, no crane. 6 wheels, 37,000 pounds of steel and sensors, driving into plunging ocean waves, and floating. Most armored vehicles that try this end up on the seafloor. This one is designed to treat the ocean as just another stretch of road. On April 2, 2026, the Marine Corps signed a $450 million agreement to buy 16 of them, and that signature moved one of the most consequential vehicle competitions in Marine Corps history into its final phase. The vehicle is called the Cottonmouth, named after a snake that hunts in the water. And to understand why the Marines are willing to spend nearly $500 million on 16 pre-production vehicles, that's before a single production model exists. You have to understand the 43-year-old problem it was built to solve. That problem is called the LAV-25. The light armored vehicle entered Marine Corps service in 1983, back when the Corps was preparing to fight the Soviet Union across the plains of Europe. 8 wheels, a 25mm chain gun, room for scouts in the back, and a design philosophy from an era before drones, before networked warfare, before anyone imagined Marines fighting island by island across the Western Pacific. For 4 decades, it did its job, in Panama, in the Gulf War, through 20 years of Iraq and Afghanistan. But 4 decades is a long time for any machine, and the fleet is worn out. The Government Accountability Office flagged the LAV as the most accident-prone vehicle in the Marine Corps inventory. Its electronics belong to another century, a vehicle designed when battlefield communication meant a radio and a map, now expected to operate in an environment defined by drones, jammers, and sensors that can spot a heat signature from miles away. And its amphibious capability, the thing that's supposed to make a marine vehicle, was always limited. The LAV can paddle across a calm river with its propellers. It was never built to swim in the open ocean, and it was certainly never built to drive through breaking surf. That limitation didn't matter much during the land wars, where the LAV spent 20 years on roads and desert. It matters enormously now. Under a strategy the Marine Corps calls force design, the entire service has been reorganizing around one scenario, a fight against a peer navy in the Pacific, waged from small islands, shorelines, and contested waters. The concept at the center of it is called Expeditionary Advanced Base Operations. Small Marine units land on remote terrain, set up sensors and missile batteries, feed targeting data to the fleet, and move again before the enemy can find and strike them. The math of that fight is unforgiving. Every hour, a unit stays in one place. The risk of detection grows. Every pound of equipment that needs a port or a pier is a pound that anchors Marines to exactly the kind of fixed infrastructure a peer adversary plans to destroy in the opening hours of a war. In that world, a reconnaissance vehicle that stops at the waterline isn't just outdated, it's a liability. The Marines needed a scout that could launch from a ship over the horizon, swim ashore through the surf, sense everything around it, and share that picture with the Navy in real time, then drive back into the water and disappear. So in July 2021, the Corps picked 2 companies to compete for the answer: Textron Systems and General Dynamics Land Systems. Both would build prototypes for a program called the Advanced Reconnaissance Vehicle. The prize at the end is one of the biggest ground vehicle contracts the Marine Corps has to give, a planned replacement of the entire light armored reconnaissance fleet. Hundreds of vehicles, with a Congressional Research Service estimate that put the eventual value between $1.8 billion and $6.8 billion. Textron's entry started as a clean sheet design in 2019, not an upgrade of an existing hull, not a stretched version of something on a production line somewhere, but a vehicle drawn from nothing and shaped entirely around the Pacific fight. Here is what makes the Cottonmouth different, starting with the number of wheels. 6, not 8. That sounds like a small choice. It is not. The Elave has 8 wheels. Most of the world's modern armored reconnaissance vehicles have 8. Dropping 2 cut weight and mechanical complexity, fewer axles, fewer drive components, fewer things to break 1,000 miles from the nearest depot, and Textron's testing showed the 6-wheel layout handled every terrain profile the Marines threw at it. Just as important, it shrank the vehicle. Roughly 22.5 feet long, under 10 feet wide, about 10 feet tall. Small enough that 4 Cottonmouths fit on a single ship-to-shore connector, the Navy's new generation hovercraft. That number changes the arithmetic of an amphibious operation. The old formula moved vehicles ashore 1 landing craft load at a time. The new math is 4 swimming scouts delivered in 1 hovercraft run, each carrying a crew of 2 and 5 embarked Marines, each capable of 65 miles per hour on land. 1 connector run puts 28 Marines and 4 networked vehicles on a hostile beach. But the water is where the engineering gets serious. How do you make 37,000 pounds of armor float? The answer is that you don't add flotation to an armored vehicle. You design a hull that was never allowed to be anything other than seaworthy. Buoyancy, weight distribution, and water tightness were baked into the Cottonmouth from the first sketch in 2019, not bolted on afterward. The hull has to displace enough water to carry its own mass, stay stable when a wave hits it broadside, keep its engine breathing while the bow plunges, and then climb out of the water onto sand under its own power. The design brief treats the entire littoral zone as drivable terrain. Open ocean with waves over 4 feet, bays, estuaries, rivers, light surf. During testing at Camp Pendleton, Textron ran the vehicle through plunging surf, the violent stretch where waves collapse, the condition that flips boats and drowns engines. It came out the other side and kept driving. A reconnaissance unit in the Pacific doesn't have to find a port or wait for a landing craft. The vehicle is the landing craft. And yet the swimming isn't even the main selling point. The Marine Corps doesn't describe the Cottonmouth as a fighting vehicle first. It describes it as a naval sensor node, a rolling antenna farm that happens to be armored. The lead variant is called the C4UAS. Command, control, communications, computers, and unmanned aerial systems. Its job is to be what Textron calls the battlefield quarterback. Consider what that means in practice. A traditional scout vehicle sees what its crew can see a few miles on a good day with good optics. The Cottonmouth launches and controls drones, and in testing it operated and communicated with a Group 2 unmanned aircraft at a distance of 50 kilometers. That is a reconnaissance bubble 30 miles deep, generated by a single vehicle parked in a tree line. It vacuums up data from its own multi-spectrum sensors and from every drone in its network, fuses it, and pushes the picture beyond the beach, to the fleet offshore, to higher headquarters, to the missile batteries that Force Design scatters across the islands. The vehicle finds the target, the network kills it. The crew doesn't even have to see through windows. An Elbit Systems head-mounted display called Iron Vision lets them look straight through the hull the way an F-35 pilot looks through the floor of the cockpit, with terrain data and battlefield symbology layered over the real world. 7 Marines sealed inside an armored hull, seeing everything around them in every direction at once. If the idea of an armored vehicle that swims through ocean surf while quarterbacking a drone swarm 30 miles out changes how you picture the Marine Corps, consider subscribing, because this channel exists to break down exactly these kinds of machines, one engineering decision at a time. The April 2026 agreement fills in the rest of the family, because the Marines are not buying one vehicle, but an ecosystem. 16 pre-production vehicles in 3 variants. The C4 UAS sensor node is the brain. A 30mm gun variant provides direct fire support and anti-armor capability, the punch that protects the scouts, with a bigger gun than the LAV it replaces. And a logistics variant is optimized for hauling supply into places that have no roads, no ports, and no friendly infrastructure, because a sensor web on a remote island is only as good as the fuel and batteries feeding it. Alongside the vehicles, the $450 million buys 3 systems integration labs, essentially the vehicle's entire electronic nervous system replicated on a workbench, where software can be tested, broken, and updated without burning hours on an actual hull. And it buys 4 blast hulls, built specifically to be destroyed. That last item deserves a moment. The only honest way to prove a vehicle protects its crew is to put a hull on a test range and try to kill it. Mines, blasts, the worst day imaginable, absorbed by a hull with instruments where the Marines would sit. Textron will build 4 of them, knowing none will survive. The vehicles themselves will be built in Slidell, Louisiana, with engineering out of Hunt Valley, Maryland. Now here's the part of the story that almost every headline missed. Textron didn't win the ARV competition on April 2nd. One day earlier, on April 1st, the Marine Corps announced it was awarding a second rapid prototyping phase to both competitors, Textron and General Dynamics Land Systems. General Dynamics is still in the fight, and it is not standing still. By early 2026, its own 30mm prototype had gone through land mobility, lethality, and ocean swim testing, with more trials running through the rest of the year. The Marine Corps is deliberately keeping 2 designs alive, forcing both companies to spend, refine, and prove, because the moment a service commits to a single vendor, it loses all its leverage over price, schedule, and quality for the next 30 years. Which raises the question every program manager in the Pentagon quietly asks: is it worth paying for 2 development programs to avoid overpaying for 3 decades? The Marine Corps' answer so far is yes, and the history of this program shows how deliberate that patience is. Textron's first Cottonmouth prototype was handed to the Marines on December 1st, 2022, at the Nevada Automotive Test Center, and even that vehicle was the second iteration, informed by an earlier alpha prototype and roughly 3,000 miles of testing. Since then, the design has logged 1,000 miles across Marine Corps mission profiles and 500 hours of trials on its electronic systems, with the Corps' own technicians probing how it senses and distributes data across the battlefield and out to the fleet. The 16 pre-production vehicles are expected by fiscal year 2028. Then comes government-led testing, not contractor demonstrations on a prepared course, but Marines running the vehicles through their own mission profiles, validating every requirement on paper against performance in the dirt and in the water. The production decision doesn't come until fiscal year 2031. From clean sheet in 2019 to production in 2031, 12 years. That timeline is itself a lesson learned. The Pentagon has watched programs fail by rushing, buying hundreds of vehicles before the design was proven, then paying for a decade of retrofits. This time the sequence is fixed. Prototype, break, learn, refine, and only then commit billions. The stakes justify the caution. The winning design replaces the backbone of the Marine Corps' new mobile reconnaissance battalions. The unit's force design places furthest forward, closest to a potential adversary, inside what planners call the most highly contested environment on Earth, Those Marines operate at the edge of the network, beyond easy resupply, beyond quick rescue. Whatever vehicle wins this competition is the machine they will live in, fight from, and trust with their lives somewhere west of the international dateline. 7 people, 1 hull, 4-foot seas, and a mission that only works if the machine works. So the $450 million isn't really buying 16 vehicles. It's buying certainty, proof, purchased in advance, that when a Marine reconnaissance team drives off a hovercraft into breaking waves, the machine under them will swim, sense, and survive. For 43 years, Marine Scouts have ridden a vehicle designed for a war in Europe that never came. The next one is being built for the war the Pentagon actually plans for, fought across water, decided by sensors, and won by whoever sees the other side first. And it starts by driving into the ocean.